Oh, we got one?
One just place to start. So card is actually a parametric type, so we
Yes.
have to actually include suit and rank information in
We would.
the constraints.
Yeah.
And in this case, are we actually able to do that with multiple dependent parameter types within the same type parameter list?
Not always. That's one of the big challenges is trying to do this, is the fact that we can't really have multiple parameter lists the way we can have multiple type parameter lists, the way we can have multiple value parameter lists. So this gets kind of out of our example. There's one of the drawbacks of trying to do any of this in Scala is you can only have one type parameter list. So you've probably seen multiple value parameter lists where we have def foo takes a bar and then an implicit whatever we're going to call it, which we could actually make dependent on some type in the instance of bar that we were given, or we can even then we can kind of stack those on top of each other. We can't do the equivalent of that with type parameters because we can't curry type parameter lists in Scala. So those of you who are more familiar with Idris or Liquid Haskell are probably snickering a bit because that dependent typing facility is more readily available in those languages, but not so much in bare Scala. What's up?
Can you use path-dependent types to do that? Like the...
Can you use path? You might be able to. Path-dependent type. So you can in some circumstances, and this is a path-dependent type.
Or like the like little tiny object thing you create with a hash.
The little
pattern.
thing.
Never mind.
No. I'm not trying to.
Like, you know how like sometimes you create like this tiny like object with a type in it, and then you like reference that type sort of thing.
Oh, okay. That might work. What's up?
So we already have a way to express that the cards have to be big cards.
Mm-hmm.
And big is defined as jacks or better.
There you
Can't
go.
we just put implicit evidence required that they take both big cards?
Yeah, we could do that. So Chris is right that first of all, we're going to have to add rank and suit parameters here. But then we can totally do that. So we're going to... This is the other reason I don't really like this in real world, because you have to do a lot of this. What's up?
I mean, I
And
know we said that if we were going to accept pairs, we only need one rank, right?
That is a good point. But we're not necessarily only accepting pairs.
Okay.
Now, for the purpose of this, we're going to take that shortcut in the interest of time. Saying pair jack or better doesn't necessarily mean they're all going to be jacks, but that's getting into poker esoterica that I'd rather dispense with for now. So we're going to go ahead and just say pairs is better. So
in
Yeah.
Scala, can you not like peek into cards? Because card is parametric on rank and suit, but you can't say like I want C1's rank. You have to explicitly pass that as a separate parameter.
we might be able to get away with that. There could be a way. I don't think I suspect we would run into barriers with it. The way we might be able to do that is if we, instead of making card, if card was not parametric, if card was instead using an abstract type parameter for rank and suit, which is, there's another file in the repo that actually went down that path, but I ran into issues, I couldn't get it to work all the way. But essentially you hit a point where even though you know that these types are both equal, the compiler will not verify. So I ran into a dead end trying to go the abstract type method for Mod 1 card, which is why I instead went with parametric types. But maybe someone knows a way around that. So that's in... Right, so that's, if you look in pokercards.scala, it uses that attempt of using abstract type parameters to model cards. But I couldn't ever quite get this to actually... It will let you compile all the constraints, but when you try to use them, it'll never solve correctly. But maybe someone else has a way around that. I couldn't figure it out. So,
Do you want to make card, like, do you want to unify now with R1 and S1 on C1, and then the same thing with C2?
that's exactly where we're going.
Okay.
So that's a function that will basically take any pair, so we're not done. And that's a function that'll take any big pair. So we can actually verify that. My Vim setup is buggy. And this is the big downside, is we would actually have to go jack, spade, heart, card, jack, spade.
Could we get around that if we added a trait called big card? So right now we're trying to apply the trait to see if the rank is big. And we're digging into those parameterized types in the body or in the type declaration here. But if we have a big card trait,
That might work. Why don't you take a whack at modeling that, and maybe we can throw that that version up on the. Oh, I pluralized those, didn't I? There might also be a way to eliminate some of this with wildcard types, especially since we're not. Maybe. I try to avoid those personally, but. So we can compile that one. Can we compile it if it's an 8? Yeah, so there we go. So this.
Can you show that line for a second?
Oh, the original one?
Yeah.
So we've tried to pass a pair of 8s into our strategy, acceptance function. But it doesn't compile. And using our nice little implicit not found annotation, we see exactly the reason why. So let's take as our next challenge.
Why does it have to be?
That's just what it's called in poker.
No, but I'm just saying from the definition.
From the definition, sure.
Yeah.
So I defined this
here,
type
okay,
class
I missed
constraint on the
that.
rank.
All right.
Oh,
Yeah.
no problem. Yes.
So, as kind of a pragmatic approach to it, like one of the things you point out there is it doesn't double define the rank and the suits and everything. If you just had that definition, the method there, instead of putting the card R1S1 and R1S2
Yeah, they're not doing as much.
list, if you just put them in an actual like a real argument list, not a type argument.
I see what you mean. All
It'll
right.
infer those, right? So you could just say, given an argument of C1 of card RS1 and a C2 of card RGS2, then your evidence still works. And then you just basically need a small helper that says, maybe what I did is lowercase card with the two types constructs a new card of those types.
Like an implicit apply, you mean? Or?
Not an implicit, not even an implicit, just like a utility method that generates,
Oh, yeah.
generates an instance of the right type.
I mean, in this one, yeah. So we can totally do this too. Let's see if this plays out. This does have the advantage of kind of bridging us back into the value level.
Right.
Um,
Yeah.
so there we go. Same error, half the boilerplate. Good idea. What was your name?
There.
Garrett. Have we met?
Maybe a while ago.
Okay.
Brian, can you get rid of the type annotation on the call to accept hand form? Like for that part from the cards?
The type annotation on what?
The call to accept hand.
Yes, it should. You are absolutely right. Oops. Yeah, not that one. So there we go. So now we've eliminated most of our boilerplate. We've now encoded a very basic strategy using Shapeless, but it has the advantage, thanks to Derek and Chris, of bridging us from the type to the value level. Because that's one of the biggest challenges of Shapeless is you kind of get stuck in the value level, or stuck in the type level, sorry, and you need a way to bridge back and forth. It's there are definitely open questions as to the best ways to do that. You can bridge pretty easily the natural numbers back and forth, but you have to know them at compile time. So it's kind of just a syntax difference, in my opinion.
Excuse me, could you show, because I was lost,
Sure.
how we lost that definition of types at the beginning.
So we just don't need it at the call site, because the compiler will infer the types
Okay,
using the values we passed in.
alright.
Anyone else a little confused by what we just did? Would like a quick has questions? Cool. So we've got a function. We can pass it 2 cards, and it'll tell us whether or not it'll compile, if and only if we're going to bet with those cards. So we're going to bet with a pair of jacks. We're not going to bet with a pair of eights. And this can get more, modeling a real strategy, and this would be kind of difficult. One thing we could do is, if I wanted to expand on this and model a much more complex strategy, I think what I would start with, and I highly doubt we will finish this in the time we have, is start by adding position into the mix. So I would model this the same way that the ranks were modeled. So we've got positions 1 through 9. And then I would probably, I don't know, it'd be an interesting question of how do you use type classes essentially when we have 2 independent variables. We have the cards and we have position. And if and only if position is over whatever the threshold is, so let's say if position is 1, position is 0, the lowest position, the worst position, I only want to bet when I have pair ace or pair king. Let's say that becomes my constraint. So I'm going to So first position, and imagine the remaining 8 modeled in a similar fashion. And so now I have, so how might I combine these two? So I only want to accept, so let's change this, I only want to accept aces or kings. I believe actually I'm going to make it easier so I don't have to write more constraints, and we're just going to call it face cards. And then we want to take position into account. So let's, so what we might do here is kind of use a permitting system. So this will be familiar to you if you've ever looked at how a weight is defined in Scala concurrent. You can only get a can await permit if you were in functions that are protected from user space. So it's kind of a can bet, not can beat. So let's say so this is a path we might go down, wherein we define this can bet trait, And we're going to define functions that can instantiate this only if our strategy is satisfied. So how might we do that? We clearly cannot model all of the permutations in one function like this. It's just not going to be sufficient. So how might we otherwise do it? So let's say implicit def first position. So this will be the function that creates a can_bet instance if we're in first position, depending on the cards we pass in. The goal being that eventually, we're going to obviously add constraints on that we eventually end up with an implicit apply that somehow, and this is not how we're going to do it, takes a position. They're not really, they may or may not be value level, we'll see. A card.
Good question. Shouldn't first extend position? Or
Yes, it should. Thank you. Ultimate goal being to get to a function like this. And full disclosure, I don't know if that's possible. So let's see how far we can get. So we're going to say that in first position, I'm going to have a position, and then we're going to have all of our various ranks. Rank 1, rank, yep.
card 2 should be, C2 should be arrow to S2, right?
Yeah. We're using the same constraint where we're saying pairs only, so we're using the shortcut of only defining one rank.
When I'm saying like line 267.
Oh, I see what you mean. You're totally right, yes.
It's like using Shapeless makes me write longer type definitions than the actual body of our function.
Absolutely. If you look at the type definitions in the Shapeless library, they get the type definitions of the whole thing, and then it's like new trait.
Okay.
Again, part of why I don't really use this in production code.
I'm not saying it's bad. I'm just,
Yeah, I mean, there's definitely an argument to be made, and there are companies who do use it, but in my opinion, it doesn't necessarily outweigh the benefits. Obviously not an opinion shared by everyone, so totally fine, but where was it?
Yeah, it's all things.
Yeah, because like, we were like, it's, yeah, it's what yes. This is this way, right? So first things so yeah. Because we define a stack of traits. Traits here, we say, prefer X. We actually to stop that. Some class. Well, if you did it, just find the first one in the stack. Right, the question is how where is that searching? Because we're going to call. Well, okay, so yeah, so if you don't, if you just don't right in that stack, right? Yeah, that would just keep going. Yeah. Okay. Yeah. Yeah, because you would say you're so like. We would get this trait from the first position. Yeah. And we said, well, we so what would that lie? Whatever logic we want to do. Why don't we just encode it as a bunch of type images and not and the type of these are works out. So the question is these whole card has another so we can press it our first excited is the series well no, we want to use that as a constraint, but we can't use that as like that. Because there's no way for me to go from a long time since right. Yeah, from this it has to return.
It can be a symbol, or it can, not symbol, it doesn't actually, it doesn't have to be something instructive. Yeah, no. Yeah, we just need to find, we're just looking for something that isn't doing this.
All right. How are people doing? I see a nod. We got one nod. Who's not doing well? It's okay to say so.
I'm struggling to find what you about use case.
That's a fair criticism. I'm not necessarily saying this is, so I find this to be academically sensitive. Obviously, we've got others who, do you want to know, because I guess it is. Someone in this area. I know this guy said he was using it for HTML generation. Not this, obviously. Right. But the concepts kind of analyze. You'll also find them, I believe Slick uses some of them. In fact, for a long time before Slick was 2.0, whenever it was that Slick finally started being able to represent records of greater than 22, because of obviously the case level limitation. A lot of people got around that using H lists, which, well, they come from Shapeless, but we have not touched them today. So I haven't provided an answer to your question of what's the use case.
Is it fair to say that like if you use something like Shapeless, you can avoid using macros that are more untyped?
I wouldn't say that because this is all backed with macros.
Sure. Okay.
So Shapeless is going to hide a lot of that from you, which is definitely preferable to writing it yourself in most cases. Not all. But most of this, all of the natural number generation underneath the hood that ultimately this is using to handle its comparisons is all done with macros.
I guess with Shapeless, you can do something that maybe you could have only done with another program. Is that?
Yeah, I'd agree with that. So who's anyone have something they would like to show off, a way that they've approached this problem? There have been some spirited conversations over at that end. I don't know if they're actually related or not. And I think Chris stepped out. So there were some people on the back row who had some interesting ideas. Anyone back there care to talk about the approach that they took? Anyone? Okay. So Chris, let's check in with you, since you're now back. So what approach are you working on?
Well, I was just thinking about the ranking of hands
Okay.
situation, and I was starting to play with whether I could use a low priority implicit trick
Mm.
to just define an ordering of hands and have each successive trait in the linearization return a lower priority hand.
Can I totally put you on the spot and ask you to come show us what you've been
I
working on?
haven't gotten far enough with it yet.
Okay.
To actually, show any code, but.
So for those who aren't aware, there's a trick you can do, which I'm not terribly I'm familiar enough to know it exists, which is you can kind of trick the compiler into defining different priority. It's not even a trick; it's officially supported. You can tell the compiler that some implicits are of higher priority than others, so that when you have potentially ambiguous implicits, the compiler will know to pick one over the other, rather than just saying, no, I don't know which one to use. Figure it out.
Could you show this for a second, the end of the line 268, the first position method, like what's the return type?
So it's returning an instance of can bet. This isn't working yet, which is why I have not gone into it. So let's see. So we've got about 30 minutes left. I'm going to say right now, I've exhausted kind of what I prepared, which I'm sure most of you realize. So if you would like to leave a little early, I won't be offended. We've got about half an hour left. Those of you still working on it, of course, welcome to stay. And what's up?
I see you've commented out not equal, and I really believe that
So the better way to do it is to use, it's not there because it's essentially superfluous. So if you do equal, exclamation, equal, that is the same thing. And that's provided by Shapeless. That's why it's commented out, because I should have just deleted it, but I replaced all the invocations with the built-in, the now built-in function. Yes?
Breaking some of that across lines, so I can see it.
Yeah, you got it. Actually,
So the overall goal here would be to implement all the rules that you have in that book, and those would just compile, right? The rules would be, like, if they are correct, that they would, so I can write a program which will not compile if it breaks those rules. And the poker game.
I would say that's certainly a very ambitious end goal.
Okay.
I believe it is possible.
Okay.
I believe it's also exceedingly difficult.
Alright. But that was like a general idea, right?
General idea. I've taken a few whacks at it, and encoding everything would be a monumental project because the rules are fairly complex. One interesting way to do it would be the fact that all of those rules are actually based on statistics. This is just distilling them down and kind of abstracting away the math. But essentially, I mean, you can define all of that strategy in terms of, given these two cards and these other variables, what is the likelihood that I win the hand? So you can define all of that in terms of statistics. And with enough bashing your head against the keyboard, you might find a way to model those calculations using this.
But, okay, so like the general idea would be like we could create a library that would allow you to implement strategies how to play poker. But for example, that would be restricted with some rules. So for example, you would say never play this hand.
Yeah.
It will not compile. You try to write a, let's say like whenever something is happening, I will play that hand. But the compiler will tell you, well, don't do it because this and that.
I mean, that we can do with this right now. It's just, you know, it's not complete. It's not going to play a whole game.
Yeah, I understand that.
You wouldn't do it this way for that. Okay, that's a perfectly fine answer. But I was trying to get at how we would do it.
Yep.
Hello.
So I feel obligated to ask the $64,000 question.
Mm-hmm.
If you want to do logic programming, why aren't you just using Prolog? Or a modern
Fair question.
Prolog?
This is kind of logic programming with both hands tied behind your back.
You're right. Well, that's exactly the reason it's the question.
So I think that in order to tie these together, given that, so the approach I took is writing a function for each position, and then I believe using a polymorphic function we could tie them all back together. I haven't figured out exactly how to do that because it's a polymorphic function that requires more than one. Should be possible.
Well, I guess my concern is this is Shapeless is not really
Yeah, this is where I would need help from someone a little more familiar with the polymorphic function offerings in Shapeless. I think that's the key to tying it up in a neat little package, but that's the point where I get a little bit over my head.
I thought that it would just be able to look it up based on what these types are.
It's like very qualifying what card they should use.
So the question is where, so I'm not trying to do the same problem here, is where you're getting that difference.
So it's just like a giant table.
Right,
If
because
you're
that,
in position.
this value has to be analysis and scope.
I mean, he's like sketching it out.
So we're going at
Right.
things somewhat back to front. We should be driving, so we should be implicitly converting.
Position, it's just dealing
I
with
think,
this.
what if we did this? I think what I would like is, what if we took an arbitrary whole cards and then put an implicit conversion from whole cards to some trait that has method on which they can invoke, which will drive that invocation will drive the implicit search, much like it's done with the ops. So that when you go to invoke.
Right, but the ops are basically just looking up, you know, it's implicitly returning back, right?
Right, but that backward then, when you invoke method on it, can be
Well, what I was wondering is like, what I'm really looking for is like, I should be able to just do like an implicitly something for position. Yes, right, and that's not what I'm looking for, instead of that, so that we can't use whole cards in some other type, so this would be like, this allow this, accept. And then, right, for some P, extend position. This would be
Oh, yeah, that's right, but then where do we get this evidence from?
Like, they're still in scope, right? Well, they're not in scope, they're not in scope if I define inside these traits. Well, I have these traits we have to import from, or no, these are senior traits that I have access to.
The thing is, when you deal with passive value type big pair, rather explicitly rather than implicitly, because that's what's actually going to drive a selection as on the C prime. So if in some scope you assign, say, your big pair got
No, it just needs to be able to find one, right? It's not like it needs to be objective.
right, but there's no big pair, there's no implicit big pair value in here.
Well, this works outside of, so like in my, so before I messed with this hand here, I was just using, this was literally my signature.
Thanks so much. Great talk, thanks.
What is it finding out?
Anyone else like a little help? Or, so, Chris, what have you gotten up to?
Floundering.
Picking on me.
You know Shapeless better than I do.
That might have been true a few years ago. I haven't used Scala in 2 years. So
Oh, okay.
I'm having to quickly rebuild my stack of type system knowledge.
Well, we're trying to basically use the ordered implicit lookup. If you have a series of traits that all extend each other, you look for implicit values in succeeding order. So you would use that to essentially rank along position to find the first one that satisfies the right position, and also then satisfies whatever constraint for that position. And right now we're running a lot of like finding the right things in the implicit scope.
Yeah.
So I think this is the right path.
So if he's going to implicitly find
Some, right?
So, for those of you who have left, who are still here, I hope you've gotten some value out of this. I hope I didn't overpromise and underdeliver too badly, since we are doing pretty basic things in terms of strategy, but fairly complex things in terms of the type system. So I hope if you had not used Shapeless before, I hope I haven't scared you off too much, and you'll kind of dive into some of what it lets you do. I'm not going to argue that encoding propositional logic is necessarily the best use case, but it's an interesting one that I find fun to kind of play around with a bit. And I'd encourage you to look into Shapeless. There's definitely a lot of cool work going on there. And especially, I would say Slick is probably the best place to look. The database library Slick is the best place to look for uses of Shapeless in production code. I'm not sure it's used anywhere else in kind of the typesafe lightbend stack besides Slick. Play might use it.
Is Slick really the best one? I think Doobie makes.
Yeah. Doobie.
Oh, good point.
Yeah.
Doobie is definitely the best one.
Yeah.
I haven't looked into Doobie ever since, actually, not since his talk here last year about Doobie.
You should definitely look into it.
Yeah.
Does Slick now use Shapeless? Because it didn't used to.
It used it for a while. They may have gotten rid of it. They used it for a while as a workaround for the 22 arity limit on case classes. They used H lists.
Okay.
So there was some polymorphic function magic, like deep in the. I think it was actually an extension. I'm not sure it was ever in the standard library. So Alex, how are you doing back there?
So actually, I was getting stuck on how do you encode like a type level disjunction? Either this constraint to be true or this constraint. But sort of more parameters will be conjunction.
So if you don't need it to be an exclusive OR, do you want an exclusive OR?
That's a normal.
So what I've done is create a trait that represents that condition has been satisfied. And then in its companion object, you provide two implicit functions, one for each of the disjoint cases that each create that trait. Provide an implicit instance of the trait. So I have an example of that.
There's also the article Miles wrote, which is
I don't have an example of that.
unboxed. What is this? It's like unboxed type disjunctions via the query power of isomorphism.
Okay.
Yeah, if you just Google Miles unboxed Curry Howard, you probably get it.
Thanks.
Yep, unboxed human type and Scala via the Curry Howard.
Yeah, so I'm sure that article provides a better way, but this is what I've generally done in the past. I'll note that you could also encode this by just simply saying less than or equal to 10. But, oh, what do we have? Breakthrough?
Yeah, I forgot I put in some parameters here. Yeah, so, well, now I gotta actually test and make sure it works. Make sure it rejects things it shouldn't.
Oh, we don't need runtime tests.
Yeah, okay.
Well, no, rejection at compile time.
Right.
Mind, so if it works, you mind showing it off?
Sure.
Got it. Nicely done.
There we go. Okay.
All right, let's see if we can plug that in up here.
Okay.
What do you got, HDMI?
Probably.
I think so.
Yeah.
I'm the fool who brought a 12-year-old PowerBook adapter to my.
I've even got a Thunderbolt, so it's even simpler. Or unless you're already on HDMI.
This is the HDMI.
Oh, okay. We'll do that.
It's not even my adapter. I brought all the wrong things. I didn't bring an adapter, and I brought the power adapter for a 12-year-old PowerBook.
Hold on, let's see here. I guess over here.
So remind us so you were trying to order categories of cards in relation to position or what?
Yeah, in relation to position, right? So
Okay. Can you bump up the font size a bit?
Yeah. I think.
Okay. So, right, so this line 270 you can kind of ignore. This is what we were trying to do with the implicit lookup based on trait linearization. So I'm going to see that. I think that should be able to work after this, but essentially the stuff that we're doing is down here, where I added the position, and then so this is just a series of implicit defs that constrain on the position in addition to the ranks and the suits. So like, for example, if we're first, we want to make sure it's a big pair. If for second, maybe you accept the 9s and higher. I'm not a poker player, so I don't know if that's a realistic strategy. But anyways, then I modified the accept hand here to basically say, okay, we're taking a position here in addition to the ranks and the suits and everything, and taking an additional argument here so that it can infer that. And then what we changed to is our evidence that we're looking for is acceptable hand class, which basically says, like this is an acceptable hand for that position, that rank, that set of suits. And then what it's doing is it's looking through it looks for an implicit definition that can produce an acceptable hand. And it doesn't actually, like the value doesn't actually matter, so I just returned null here. But yeah, so it's figuring out which of these is the first one that it can find. And in this case, 7 of hearts is not a big pair, so constrained on the first position, it doesn't match either of those. Previously when I was on, let's see here, what was it? I had Jack of clubs and Jack of hearts. And that's similarly, and so that compiles, right?
Awesome.
So it's able to find that.
So we've now got a poker strategy based on 2 variables.
Yeah, no.
In the type system.
The trick here is that, because we're using these kind of implicit definitions to find it, is you have to come up with a completely disjoint set of these, right? Because if you have anything that's overlapping, you'll end up getting ambiguous implicits, and it won't compile for other reasons.
Which doesn't really match the real world, but it's fine for our purposes.
Right.
Cool. Great. So big thanks to Derek for
well, it was
figuring
Chris's
Chris
idea
and Derek.
in the first place.
So thank you for sticking out the entire workshop. I hope you learned at least a little bit, and enjoy your lunch.